Hi everyone and welcome to another YouTube video. In today's video we are going to be trying to learn how to get the expected value, the standard deviation and the variance of a discrete probability distribution. In our last video I actually gave us a simple data set, a discrete data set, and we actually tried to learn how to get the probabilistic value attached to each of these random variables, and then we also learned the concept of cumulative probabilities and complement rule. So I'll be linking a video in the top right corner so you can just go check that video out and see the data set I am trying to talk about. In today's video we are still going to be using the example we used in our last video, but this time we are going to try to get the expected value, the standard deviation and the variance of the discrete probability distribution. So without further ado, let's actually jump into the video and start learning properly. So the first question you're going to be asking yourself is, so what is expected value? And the expected value is just a way of getting the average of random variables that have a probabilistic value attached to them. Or we can say the expected value is simply a way we used to get the mean of variables in the long run. So in simple terms, expected value is actually equals to population mean. So that means if I give you a discrete probability distribution and I'm telling you to get the expected value, it simply means that I am also still telling you to get the value of the population mean. Please note that the formula for the expected value that we are talking about right now, it's actually quite different from the arithmetic mean formula that we used to know, but in the long run they kind of have the same meaning, and that is the meaning of average. So the question now is, what is the formula for the expected value of a discrete probability distribution? Now the expected value is actually equals to the sum of the product of each of the random variable of a discrete distribution and the probabilistic value. So that simply implies that if I have a discrete probability distribution and I have my random variable and then I have my probabilistic value, then if I decide to multiply each of the random variable with its corresponding probability value and then I sum all of those values, then definitely I would be having the expected value, aka the mean of this distribution. So let's go back to the previous example that we talked about in our last video, where I talked about this my friend that is a caterer and he decides to collect the number of cakes that he sells in 1 week so that it can maximize profit. So from our data set we can see that we have the days, we have the number of cakes, which in this case of ours is the random variable, and we have the probabilistic value attached to each of those random variables. So we have 3 columns right here. So for us to get the expected value, we have to add a new column towards the right, and that column is going to be the column of x times p into bracket x is equals to x. So that means that each of the random variable multiplied by its corresponding probabilistic value. So let's go. We have our 10 times 0.1, that gives us 1. 15 times 0.15, that gives us 2.25. 20 times 0.20, that gives us 4. 5 times 0.05, that gives us 0.25. 15 times 0.15, that gives us 2.25. 10 times 0.10, that gives us 1. And 15 times 0.15, that gives us 2.25. Now we have each of the random variables being multiplied with its corresponding probabilistic value. So the next step is for us to sum all of those values for us to be able to have the expected value. So let's do that. 1 plus 2.25 plus 4 plus 0.25 plus 2.25 plus 1 plus 2.25, and when we do the math we have our answer to be equals to 13. So that means the expected value of this distribution is actually equals to 13. In other way, we can say that the mean number of cakes that Billy is supposed to sell in a week is actually equals to 13. So the next thing for us to get is the variance, and the variance has the same meaning as the variance of normal univariate analysis. That is, the variance and the standard deviation actually determines the spread of the distribution, just that in this case the formula is actually a bit different, but in the same time it tells the same story. So whenever we are working with a discrete probability distribution, the formula for the variance is actually equals to summation x minus mu all squared times p of x, where your x represents each of the random variable, Your mu represents the population mean, aka the expected value, and then the p of x represents the probabilistic value attached to each of the random variables. So this simply means we are trying to square the deviations of each of the random variable and then trying to multiply these deviations with each of the corresponding probabilistic value. So let's move into our table again and try to add some additional columns for us to be able to get the value of the variance. So we are going to be needing a column for x minus mu, which represents the deviations of each of the random variable from the expected value. Please note that the mu in this case of ours actually represents the expected value. Like I said, your population mean is actually also equals to the expected value in this case of ours. So we need a space, a column for x minus mu. So that means each of the random variable minus the expected value. So that means that 10 minus 13, we have our answer to be equals to minus 3. 15 minus 13, we have our answer to be equals to 2. 20 minus 13, that gives us 7. We have 5 minus 13, that gives us minus 8. We have 15 minus 13, that gives us 2. We have 10 minus 13, that gives us minus 3. And we have 15 minus 13, that gives us 2. So the next step is for us to get the squared of the deviations, that is x minus mu all squared. So let's go into the worksheet again. We have minus 3 squared, that gives us 9. 2 squared, that gives us 4. 7 squared, that gives us 49. Minus 8 squared, that gives us 64. 2 squared, that gives us 4. Minus 3 squared, that gives us 9. And 2 squared, that gives us 4. Now, after having the square of the deviations, the next step is actually for us to multiply each of those deviations with its corresponding probabilistic value. That is 9 times 0.1, we have our answer to be equals to 0.9. 4 times 0.15, our answer is 2.25. 49 times 0.20, our answer is equals to 9.8. And we do that all through. We have 4 times 0.15, and that gives us 0.6. And these are the list of values that actually tells us about the product of the square of deviations with its corresponding probabilistic value. Now, when we decide to sum all of those values, we will be able to have the value of the variance. So let's sum it up. 0.9 plus 2.25 plus 9.8 plus 3.2 plus 0.6 plus 0.9 plus 0.6, and that gives us 18.25. So that means the value of the variance of this discrete distribution is actually equals to 18.25. So the next question is, what is the standard deviation? And in simple formula, the formula for the standard deviation is equals to the square root of the variance. So that means if you want to get your standard deviation, you have to take the square root of the variance. So our variance is actually equals to 18.25. So when we take the square root of 18.25, we have our answer to be equals to 4.272. So that simply implies that the value of the standard deviation of our data set is actually equals to 4.272. So let's recap the whole thing. We have the expected value to be equals to 13. We have the value of the variance to be equals to 18.25, and we have the value of the standard deviation to be equals to 4.272. And this is how you get the expected value, the variance, and the standard deviation of a discrete probability distribution. If you learned something new from this video and you actually enjoyed this video, I would really appreciate if you can give this video a thumbs up, and also subscribe to this YouTube channel. Do you have any question for me, or you feel like I missed something? Please go down to the comment section and drop all of them. Definitely I'm going to attend to them. Thanks for making it to the end of this video, and we see you in the next one. Bye for now.